I think it's okay. I am leaving now.
Yeah, perfect. Thank you.
Thank you.
Also, which comes like biology.
Usman, we currently are not seeing your presentation mode. So if you could click swap displays on the top left. Yes, swap displays. Perfect. You are now in presentation mode. You can say continue to share. Yes.
Okay, so please guys, make yourself. Was me or you? No, it is. You are it.
Muted.
Oh, sorry. What's we have to fix it. Where did it come from? You have to set from here.
I think you can just you can go ahead because behind the time.
Oh, okay.
You can tell everyone to turn on the camera.
Hello, everyone. Morning. I think.
Morning, General.
Morning, yeah. Can you turn on your camera to just see if you are really here? Yes. How many songs do we have currently?
We have hey, we have just four.
For currently?
Oh, five and five.
Have to minimize it.
No.
So for the participant, how many we are currently?
Four. I was counting through.
Okay, we have Victor, Kaiser is here, Rosaria. So let's wait maybe 5 more minutes. See if more people are going to join.
Usman, while we're waiting, do we have any general announcements that we needed to make?
I don't understand what the question.
Do we have any general announcements that we need to make?
No, not now. I just want person to confirm if they were able to open the share material. that I have sent on Friday? If yes, that will be enough for this session.
All right,
If
great.
anyone-
Guys, if you could give us a thumbs up or put it in the chat to make sure that just to confirm that you have access to the material today, all the shared material. Great, thanks, Kaiser. Thanks, Sylvian. Thanks, Dowdy. Thanks, Lambris and Victoire. So we now have Arsene with us. We have Ayodele. Is Ayodele the same as Babalola?
Yes, it's the same as Babalola.
Okay, thank you.
Oh, there are two more.
So we've got 7. I think we're kind of almost at a quorum. I'm trying to see who's missing. Is it Annabelle who's missing?
Yeah.
I would say for the sake of time, shall we start? And we just hope that Annabelle will join soon.
Like that, yeah. Thank you. So thank you everyone for joining this new session about introduction to spatial data in R. And this session will be led by me, Usman. I think you remember me. I was leading the part session also. And will be facilitated by my colleagues Yasin Pokoda and Dr. Kunal Akacha. So the main objective of this session is to understand spatial data, especially the vector data, and also to be able to make a map of the spatial data that you could have. How this session is going to be. So first time I will present some slides about talking the general themes of spatial data and also what type of spatial data we are going to explore today. And after that, we will have a little break of 5 minutes and then to jump to the programming practice, and then finish with some closing remarks or some discussion. So thank you for filling the press survey form. So when I explore it, I realize that many people are somewhat familiarized with spatial data. Maybe it could be they were using spatial data with QGIS or ArcGIS, but also R. It's so good to hear that. And also those who are using R with spatial data, they are very familiarized with packages like Ceph. It's very important to read spatial data. And the more used package here is ggplots to make fancy map, those nice visuals also. And about the course, it's very important to hear that you are very interested and you want to gain something from this course, and we will do our best to help you understand the spatial data. So why spatial data matter? So spatial data reveals where behind events and trend turning raw numbers into actionable insights. For example, in our domain, spatial data allow epidemiologists to visualize and target diseases. And the fundamental reason spatial data is essential includes pattern recognition, visualizing data on maps, uncover relationships, and trends that traditionally spreadsheet completely miss. For example, if you have spatial data and you have only a Excel sheet, maybe you cannot understand what really includes this spatial data. But when you make it as a map, you will see, for example, in this map here, there are different patterns in different areas, which are very informative for epidemiologists or scientists. But it also informs for decision making by adding vital geographic context to standard data, helping organizations optimize asset locations, allocate resources correctly, and manage complex network. So in the domain, in the field of public health, for example, malaria control, if you have spatial data mappings like this, you can identify which areas you have very high incidence and which are very low incidence, and then in order to know where you are going to strengthen your interventions and how you are going to plan also. Also, spatial data help to understand fundamental correlation. It links infection rates to geographic features like elevation, proximity to reservoir bodies, water bodies, and vegetation. And for example, if you have prevalence or incidence map like this, where you have some high incidence, you could also question what is happening in this location, and then by checking also the spatial distribution of other variables in order to try making a relationship. Now, as you mentioned that most of you have used spatial data, I would like you to tell me why spatial data matter. Please, can open your mic and tell me what do you think that spatial data is very useful. If you cannot talk, you can write on the chat, and my helpers will read the question or the response. For example, Babalola, Have you been using spatial data?
Yes.
Okay, fantastic. So can you tell us maybe one important thing that you were found with spatial data?
Okay. One importance.
Why spatial data matter?
Okay. Why spatial data mapping? Hello. Can you hear me?
Yeah.
So you said why using spatial data mapping is sometimes it's also used for navigation, especially if you want to go to specific locations. You can also use that spatial data mapping to do that, to achieve that.
Okay. So we don't hear you well, but thank you for your intervention. Someone else?
There's a bunch in the chat I'm just going to read out. So Victoire suggested understanding the link between some dominant vectors like funestus with proximity to water bodies. That's beautiful. Taiwo mentions to visualize patterns. Victoire again to understand links between vector composition and vegetation. Dowdy wrote to help us to tell us where things are and their distributions and relationships among them. That's wonderful. Sylviane said to estimate resistance in mosquitoes, for example, the effect on intervention strategies in a certain area. Witness has suggested it helps handling huge data and to deduce hotspots, which is very, very true. Thank you.
Yeah. Fantastic. Thank you, all of you. So, struggling to move this slide.
It's not moving.
Yeah, it's moving. So, basically, data or information that identifies the geographic location of feature or boundaries on Earth. So, we have data that can be mapped as spatial data. More generally, it provides an additional dimension by which to explore and understand data relationship. For example, here we have two tables. The first table, we have the feature like location, year, disease, and confirming cases. When we only stop this table, we don't have spatial data, and we call them no geographical data. But if we have the coordinate like longitude and latitude, we call them geographic information. And by adding these two new features, it will give us a table with spatial data that we can map. Understanding the spatial data is very important also to know the coordinate reference system, CRS. And for example, we have different geometric form. We have circle, sphere, but generally when you are seeing how the Earth is represented into a page or two-dimension surfaces. This representation is called ellipsoid, which is a mathematical model of the Earth shape. And commonly or by default, we have the WGS 84. Can someone tell me what means WGS? Yeah.
Is it what your coding system 1984?
Can you repeat, please?
Is it what your coding system 1984?
Yes. World Geologic System 1984. 1984 should be the year where which this system was established. And for this system, we have these components. We have this horizontal line. You see here, we have this line, which are going to give us our longitude. And we have this vertical line, which are going to give us the latitude. And then for any location, you could have a point where you can collect your longitude and latitude, which represent your coordinates of your location. But to be able to see the entire globe, we need a projection. A projection is a method or formula to project the globe onto a flat surface. Without this projection, you cannot properly see the entire Earth into a two-dimension page. And then when you have your coordinate longitude and latitude, they are measured by default in degree, but they also can be converted in meter that we are calling a projection. As I mentioned, so to be able to see the entire globe to a flat surface, we have to project, and there are different kind of projection. So at the top we have the Mercator projection, and we have Robinson projection in the middle, and we have this box homomorphic projection at the bottom. So generally we use the Mercator projection. I don't know if someone use in his analysis the other kind of projection and why. If there is someone who is using the Robinson or box homomorphic projection, you can explain and tell us why you are using that instead of Mercator. No one? So, okay, now after having this geographic coordinate system, so we need to be careful about the CRS, because sometimes you are joining or overlaying different layers, so you need to check about the CRS. If your layers like shapefile or raster that we are going to see next step are in different cells, they won't align correctly on a map. So it means if you want to join or extract or overlay different layers, they should have a same CRS. And The default, as I mentioned, is a WGSS 84. For the use of projection, we have the UTM, which represents the Mercator. But in some other location or area, we have some existing CRS, like the British National Grid. It means maybe where your data come from, you might use adequate CRS for that. About reproduction, so there is a function in R called ST transform, which can help you to project your layers in order to have the same CRS. So the default one is WGS, which has this number 4326. But when you want to project it to get your measure in meters, it will be the UTM. And for example, here in this different map, you can observe a little change between the two projections. Now, during this session, we are going to focus on the vector data, and the raster data will be the next session. What are the type of vector data? So, vector data have a geometry, shape, and position, and attributes, which can have properties such as color, size, prevalence. We have the point data here, where you have the points, and in every point you have your longitude, latitude. We have also the lines, the middle, which is a set of ordered points connected by straight line segments. We have also polygon, representing the administrative boundaries or area. Okay. So all these could be represented or included in one big area. So it means you have to know what kind of data you have and understand what it contains. So for the attributes, for example, let's take a map at the left is only these polygons, and inside this file, if we have these different fields or columns, we could create a map which have different pattern of color depending on your columns that you take. For example, here, if you have the original map, we add the attribute need can represent this map where you have your different color will represent the different values of your main variable. It means your attributes are going to differentiate the color of your polygons based on also the palette that you are going to foster. As vector data, it is a shapefile, and generally when you have a shapefile, you have different extension. So you have the dot shape SHP. It stores the actual geometry of the feature, your points, lines, or polygon. You have the dot SHX, which represents the shapefile index. You have also the dot .dbf attribute data file, which is a database format table that stores the attributes, no spatial information. It will not include your longitude, latitude of each picture. And you have also the dot .prj, which represents the projection file, defines the coordinate reference system, and projection information used by the shapefile. And you have all these files accompanying your shapefile. So to analyze or manipulate shapefile, there are different tools. We have QGIS. Who is very familiar with QGIS here?
I use it a bit, but not really advanced.
Okay.
I also I use ArcGIS.
ArcGIS, yeah. Kunal, did you arise on her?
Oh yeah, I'm an old ArcGIS user back in the day when it was version 3.
Okay, yeah. So here is some comparison between QGIS and R. So you know QGIS, when you open, you have these different components. It's like a static interface, where like graphic interface, where you can click and add what you want. It can give you very nice maps, but the most of time there is no need of coding. Even it could be possible, but most of people are using that to avoid coding. But when you go to R, you have to code. It's a programming language. But also, when you create a R file, it will be reproducible for someone can save it and send to someone who can like reproduce what you have done. And also, you can make very nice faceting of time series or multi-map, and are also contain plenty of packages like SF, Terra, ggplot. It can help you to do your work easily. So, for example, if you are using the package ggplot for your spatial data, how very easily you can implement it. So you have to load your shapefile data. First, you have to load your library, ggplot, and library SF for reading your shapefile. You have ggplot, data equal your shapefile, and you put your SF to define those attributes that we want to show. And then to change color palette, you can use this scale fill list. Maybe if your attribute is continuous, variable, or discrete, you can choose here, and you can use a term. So GeoSF automatically understands the coordinates reference system and geometry from an SF object. We have also main functions for the shapefile. To read the shapefile, we have to load the package SF, which contains the function streads. And we have to inspect your shapefile. You can call the function stcrs or plot it. To transform from one CRS to another one, you can use st transform, which can help you to reproject from WGS84 to UTM. For visualizing, you can use the plot vector. You can use a function plot defined by default or ggplot, which can give you very nice map. So if there is not question, so we are going to jump. First, we are having 5-minute break before starting the practice. Also, to do not forget filling the post-workshop survey after. Thank you so much. If you don't have questions, we have 5-minute break. And then we come back for practice. See, I'll see my screen.
Yeah, I can see the codes.
You stop search 7.
It's already time. You can supposed to end at 11:40 here.
11:40.
Oh, we're out of time. Hi.
Enough for 20.
Let's give it 20.
Yeah.
Oh,
We start in 2 minutes. Okay, so welcome back. So let's start the practice part. So before, after opening your R Studio, please from here, because I think now everyone is very familiarized with R Studio, where you have your files. So please go to where you have saved your material. For me, for example, it was saved in this folder. Okay, spatial data. So the material is here. Please go to this, and you have to be sure that your R console is pointing into this folder. So how to check that? You have to do get WD. For mine is pointing where the material is stored. So please do that in order to facilitate the reading. If anyone has some issue about that, you can ask the chat, because you have this. But also you can, for example, if you are here, you can take the path of this by copying this, copy folder path to clipboard, and then set your working directory. Then set WD, okay, and you set your working directory. You click OK, it will point you where your data are located. But for mine, it's already there, so I don't need this. Okay, so and then you open your vector data skeleton script. Was in the script. Vector data skeleton script, which is this one. You open it. Okay. And then, as you already learn about quarter, we are going to create a quarter file and implement this content. So I think anyone here remember how to create a quarter document. So how to click here where you have the plug, and from there you have quarter document, you click quarter document, and from here you give the title of your document. I can say spatial, maybe vector. Please give it as you want, not following me. Vector in session. And we are going to take the default one to export the document has HTML, and then you create. Okay. And from this, as we have this default content, so you can remove what you don't need. So I don't need this part. I will fill it myself. And you remove any text, you remove the chunk here, this, because you are going to have some script. You can leave it or you can remove everything. And you can leave the MR parts. Is it okay for everyone? So from here, we are now going to take content from our vector skeleton. Okay. You take this content to copy here and paste it in our partner document. So just copy first these goals. So remember, if you copy with if you copy with the hashtag, remember is going to create the first level of heading. Okay, so you have to create to copy without the hashtag. So let me create. I want my title to be the first level of heading, and then any title section to be the second level of heading. To create headings level, you have to use this hashtag. When you click here, double hashtag, and you space, it creates here a heading level 2. And so I want this to be want to try your goals. Enter. So I want to copy now the contents of the goals. And copy. Paste here. Copy. Paste here. Copy. Maybe someone has better way to do this, but yeah.
You can copy everything and then paste on the new quarter document, but you need to switch from the visual to source so that it doesn't.
When you are copying, you have to be with the source first.
Yes.
You copy there and come back to the visual.
Yeah.
But you have to remove the hashtag after.
Or the hashtag. I'm not sure if that shortcut is working.
So it's up to you.
Yeah, I was trying, yeah, but now it doesn't work. It's only working in the chat.
Yeah. So what we have created is the amount part, very simple. It was the default. We have so first part is the goals. We have these different goals. Even if we are not going to see all of them, but just to describe them here. Now, after that, we come back again to our skeleton. The first thing is to set all libraries. I can copy this to set libraries and come here. After my goals, I create a new section heading. So called setup load libraries creates output folder. Okay. For that, now I can add a text. So I can add a text here before the R script. So for adding a text, you don't need to put these headings or hashtag. Just load here all required packaging. You can add everything that you want here. So text, it will be shown like this, will not be modified. So now I have my chunk here. I want to add these libraries. So to add them, I'm going to just copy them and paste. So it's an environment. I passed. So for this, you can comment these two packages. We are going to use library dates for the dates of our data. So first library, we are going to use SF. So to reach the shapefile.
So the explain that library is a
Yeah, but we don't have to wait on that we can hardware. So we have this different library. I hope everyone has already installed all the libraries. So to check if they are already installed, you can run this. If you run without error, it means all libraries are installed. If you have error, you have to install them. And I hope all of you know now how to install also libraries.
there's no library called team.
Yeah, you have to install it. Or you can comment it right now and follow the text when it is required to install.
Okay.
Yeah.
Yeah, I think that's the best.
Yeah, you can follow everything that is not already installed. You maybe can comment and follow up. So from this, if you don't create output folder yet, you can copy this Okay, and then pass it here. So here is taken the date of today. It's naming of folder like outputs, adding the date of today, and create the outputs in your folder. So I have an output here, but the date was 8th of July, not today. I'm going to create a new output folder. So let me run this. And you see here, you have output 13th of July. That's it. The output will serve to store every output that you have created in this. Okay, I think it is not rapid. I see.
It's not fast.
Okay, after answering that you have your libraries and you have created your output folder, we are going to read, inspect, this is our shapefile. Yeah. Sorry. For that, I am going to add a heading. I'm calling this reading, inspecting, or shapefile. And now I can decide to add some text before the R part. So I have the text. So you just go and copy this. First here. Just go and copy and paste without the hashtag. Okay? Without the hashtag. So I have this text explaining what we are going to do. In this text section, we read a shapefile containing fakeland boundaries. We then explore how to insert columns, check geometry, and do quick plot. To do that, as it is a script, we have to create a script environment. So to do that, we have to put these three things, open bracket, R, go out, and it creates your new R script. I think it was same with R markdown. After that, now we can copy this part up to here. We can copy these parts up to here. Not copy everything yet. Please leave it here. Okay. So, and then come paste it here. Okay. Now, after this, we are going to read our shapefile by using the function stread. We complete it here. Stread. Now we are going to use stread after putting these two quotation. I just click tab in my computer and it's asking where my shapefile is located. So it was in data. Tab again, raster. Tab again. not Rasta, sorry. We are in shell. No. From data, we have, oh, seriously. We are in shapefile. So we have to read this file .sfp. It was here. What I did, I put the st reads parentheses. I create this quotation, and I am clicking tab to send me where my data is located. Let me be sure that was the one I read. Yeah. Okay, so after reading this, I can only run this to be sure that the reading is working. Yeah, it reads my shell file, no problem of path. After that, we can inspect here. After just here, just this part. Yeah. So after that, I can check what this variable content and comment this tagline. You can put this or make print. If I run only this, you see down what is giving me simple feature collection with 46 feature and 5 fields. So for here, 46 feature are the number of your boundary, admin boundary inside the country, your fake country. You have 46 polygons. And 5 fields are this number of columns. It means in every boundary you have collected 5 variables. And you have polygons. At dimension you have x, y, representing the longitude, latitude. Bounding box you have these values. And when you remember here, the geodetic CRS is WGS 84. It is the default one. It means these values are in degree. If you want to change these values in meters, you have to change the CRS to UTM. And here it's showing only 10. This is a 10, the first 10 line, but it has to show 46 line entirely. Okay. In every line represents 1 polygon. You see here, for example, admin 2, you have Zilla. Okay, these are the geometry. Right? And then if you want to check the column name, you can also only put Fairland as it is, but you use the function names. If you run this line, it's giving you the 5, the names that you have here. Okay. And then if you want to check the status, you can use the function status. It's going to give you the coordinate reference system. which is the World Geodetic System. Okay, where you have the values in degree. You have EPSG 4326. Okay, and then now you can check what is the spatial distribution like some maps. We use here the function plot. This function is going to show you the 5 fields containing included in this shapefile. Now, country ID, which was uniform, it was only identity. Country, it is within one country, but the other things are varying. You have admin 2, the second administrative boundary, admin 1, the first administrative boundary. Okay. So now, after creating this, we are going to save in the same folder where you have the materials, spatial data. I'm going to call it slide section 1 .qmd. After saving this, you see it here. Now we are going to run it to export as HTML. To do that, you have to run here in blue. So when you click that, you wait, it's processing. Supposed to give you, okay, it says that, so let me comment this CRS. So just comment the CRS and run it again. Run it again. So you see it has produced this HTML file. You see HTML file here. It has produced this HTML file. So now we are going to create classrooms to check if you are really following what we have done. So Punam or Tokoda, could you
Sure.
help?
So we're still good with 3 breakout rooms?
Yeah.
3 rooms?
Yes.
All right.
Yes.
So everyone, we're just about to go into breakout rooms and you will have one of the hosts, one of the instructors with you. So anything that you're struggling with, we'll talk through them with you, okay?
Yes.
Annabelle, are you with us? Annabelle? Annabelle, you need to join your room. You would have gotten a thing to click.
Hello, Annabelle. Yeah. Sorry. Yes, we are done.
Okay, perfect. We are having this internet issue, David. David?
David is frozen.
Yes, frozen.
You can tell him to mute the microphone.
Video.
Yeah, the video, like.
Then you can mix your video to optimize internet, maybe. SB bar, yeah? SB bar, I will send it to Punami.
To the main room.
Yes.
Did you didn't you say?
15 minutes.
Yeah, was Annabelle in your room?
No, it's only David. David?
Annabelle, I didn't see her assign in any room. Annabelle, are you there?
No.
She's here, I think.
In your room.
No, in the main room. Annabelle,
How to come back in the main room?
leave.
I use this.
Yes.
So, thank you, Victoire, for creating this. David, we are having issue of internet. So now we are coming back to the main room, yeah?
Annabelle.
Recording in progress.
Ah,
Hello?
Can you call Annabelle? Annabelle,
David? So,
I can see David here.
David, can you hear me? So the other guys are not here.
Oh,
Like this, can you hear me?
let me
yes,
send-
yes, I can hear you, Osman, very well.
Yeah.
Okay, you can contribute, yeah? Let's wait for people coming back. David?
No, David is there,
But we can talk.
even his microphone, I think there is issue. He's joining without microphone. Did you tell him
Yeah,
what time?
20 people, 15 only.
Can you go there? You can go to our room.
Go there.
Hmm?
Go there and ask them to come back. Even Kaiser. Kaiser!
Or
We need to continue.
Where is Kaiser's room? Kaiser's room. Yeah. But I don't know, where do you go you cannot access the breakout room? I don't see them anymore, but before I was seeing them.
So can you
When I was in the room where I could see they are part of.
Yeah, we have in the
No, they are not.
No, I think, hello, Connor.
Yeah.
So we managed to visualize the country ID, country admin 1 and admin 2.
That is what I have in my screen. Country, it's that is not okay.
Oh, yeah. We also arrived there.
I try to plot contrast me one, contrast me two.
So we can do fake length. We don't see country admin 1, country admin 2. Let's just open up something else. Or are you talking about the fault in your window here? The country ID, country date code, admin 1, admin 2, admin 1.
I think that is what he means.
Okay. Awesome. So let me ask you a question. What attribute is this in the shape file that you just loaded?
Yes, the damage the attribute. You are asking question about what I have in my plot or just in the file that I downloaded it.
I'm asking you, what attribute exists in the shape file that you have just loaded?
It's an attribute.
Let me check. So
So do you want to talk about this by attribute?
yeah, I think you need to. I think that you need to explain really the attribute about
I
the
don't
file.
need to explain it, you have it, you just talk about it, but what attribute?
From the presentation, like I see the one which gave us as an example, the attribute was like name, like the clothes was showing the name inside. So I find it attribute.
So is the mean always the attribute that's there?
Not a must mean, maybe you're closing maybe a normal, maybe that's an attribute.
That's normal.
Example, a normal teacher.
But what is an attribute?
I think it's a feature or data values that you are representing on the map.
Exactly, remember that it's a table, it's the information in the table, those attributes. So the plot already tells you my attributes inside my table, a country ID, country zip code, admin 2 and admin 1. So you plotted all the attributes.
Can I ask a question that the coordinate is coordinate an attribute?
It's a really great question. Technically, geometry, which is where your coordinates will fit, which is all the spatial information, it is an additional feature, which is why it doesn't swap out. It's the reason why you can make the map. So it technically it's an attribute in the sense that it's information in the table, but it is different because it's geographic in nature.
Take them to
Yeah, which is why I don't have,
Sorry for that.
yeah.
So can you explain structurally? Did you say that geographical coordinates are also an attribute?
Yes, because they're part of the table. Just want to physically see them because there's a reason why you can draw them out. So they are considered everywhere. Yeah? All right. So we have exercise, we have activity today. So you have made a plot, but what is needed to transform this? This is the second part. How would you transform, or what we call project, the country state lens to a different point of reference?
I think she's
Solution from useful functions to the file. Remember?
Student.
yes.
So, Dr. Puno. So Usman is saying that is the second part, but we need to come back to the main room.
Okay. This is one of the written in practices. So, Koda, do we need to come back?
Yeah, unfortunately. we
Okay.
need to go back.
So we're closing all breakout rooms?
Yes.
We need to close all breakout rooms and join in together?
Yes.
Yeah.
All right, so see you guys in the main room then.
Okay.
Hello. Welcome back. I hope all of you were able to open all rooms. Yeah.
Do we need to go back to?
No, it's okay. Yeah, so I hope everyone, most of you were able to create the quarter and fill this for the fast. Because in my room, I had Victoire and David. Victoire were able, but David had issue of internet. He was frozen. And how was it in your respective rooms, Popoda, Puna?
So in my room, Arsene was the one who shared the screen, but he hadn't attended the Quarto session, so we talked through Quarto, but we kept to the R script, and everyone was able, they were able to run it. Correct, Arsene?
Yeah, so for me, it was only sleeping. And nights, it was sleeping and Victor, so they managed to follow everything. There was a small error, she was getting sleepy after the CRIs. So we just resolved it.
Okay, so now everyone can read the shapefile, inspect the shapefile, recognize what are the different attributes in the shapefile, which are shown here in this maps. That's okay. After that, we are going to the second part. When you come back in our skeleton, which is about transforming the CRS, like moving from one CRS to another one. So let's take this. For those who are able to take the quarter document, let's continue. Then a second or a new session called transforming CRS. Create script environment. Now let's just copy from here to these two, or let's go up to the ZZ plot one here up to line 92 and pass it here. So now we are creating a new variable, FECLAN HD 40 26. by using ST transform function, ST transform function, and then here we put the codes. So to say that this shapefile here is getting the CRS WGS 84, which was the default one, it will not change something, but just we are assigned to be compared to a different one. So let's run this, and then we can check the current series of this shapefile. You see, it has the default one, WGS 84. So after that, we want to transform this, like to reproject from this default one to UTM. We are calling the new ship file reprojected as speculated UTM. We use the same function ST transform. We take the original ship file. Now for UTM, so code is this one, 32,736. Okay. And then we run this. You can check again what is the current CRS. And for here, you see now change. You have the new EP user input here, and now it is UTM done 33S. Compared to the initial one, where here it was only WGS 84. Okay, so here you can plot this, but let's comment this and come here to compare the two new shapefile with different production. So when you run these two, you will have here the output. The first one was the shapefile with the default CRS, and the second one is projected to UTM. And now you will notice a slight change of the map. For example, here, when you compare this to this part, you see it has moved. This has moved up to these cells. In this project, it has changed the position. Is it okay?
This one.
Yeah.
Maybe front expand the page. She cannot see the screen.
She cannot see the screen.
Yes. Doesn't see the screen.
Guys, are you seeing my screen? Yes.
Witness is
Who is not seeing the screen?
witness.
Can you ask
Oh.
witness?
This is how what she can see. Can you check out the chat? She can only see you.
Oh, but
Your video, like you
Punam, can you see my screen?
So I can see your screen. So witness, it might be an internet issue. I'm just going to move you to a breakout room and work with you to make sure that you can see the screen again. All right, really quickly.
Yeah, perfect. So now, guys who were able to create the quarter one, up to here, we can run again to see what. So before running, let's just add our name here, maybe author name. Author name. Okay. But also, you saw when you run, it's showing even the default warning, some warnings. So you can decide to do not show in your HTML document all this warning, yeah? For that, you have to add here another component, execute. So for echo, we are going to set equal to say we want to see the code here. And for warning, we want to set it false to say, you don't want to see. For example, if you load your liquidate packets or you read your something, so you don't. Okay? Just set this and run it again. And run it again to check what is the buttons. Okay, so after that, I don't know if you are able to see my HTML open. Or you can prepare some. Yeah. But I'll see. I'll see my. I'll see.
Yeah.
So now I have run. So it should create a HTML document. You can open it. If I open my HTML, is it visible?
Yeah.
Okay. So now you can see it's more clear than before, where you had all these warnings. Now you have your goals, author name.
No, it's not this.
Huh?
Is it on your side?
Is
the rendered one.
They are just saying the Arrow Studio ID.
Is this one? I don't do stuff. So when I share again, what I'm getting, you see now what I'm getting after rendering without echo, with echo, without warning. So I have this different component, transform, the two results after transforming. WGS, and UTM. Okay, so let's go back to our art studio. Then add here. Okay, after this, let's create a basic map. Come to your instruction, copy this section number 3 and create a heading. So at the text, for example, let's press some maps. Parts are still part. So now we want to create a map. Let's just copy this. No. Just this one. This is equal one. Okay. So now I'm creating the map with GZ plot here, where my data will be the fake land, the original one. So in this, I want to plot an attribute which is admin1. I call it in my except function. In the legend, I want to give the title admin1, minimal 10. Okay. So let's plot this default GG1 map. Run this, and you see what we have here. So we have 5 polygons, admin1, and every admin1 is colored by one specific color. And we have here the coordinates, longitude, latitude. Okay, and inside we have the different boundary. So can someone tell me what are which attributes have these different boundaries inside one admin1? For example, inside west, we have west is here, and we have other boundaries inside. Normally, west should be all this where we have the same color, yeah? This is the west, maybe region or department. But inside we have other boundaries. Can someone tell me which attributes in our shape file is represented here? Yeah, open your mind. So remember, we have this. Let me show. This is my R console. If I say names, Techland, I have this attribute here. So in the map, I want to shows that we admin one, and inside this admin one, I have other boundaries. Can someone tell me what this could represent?
Let's say having
Admin, yeah. Okay. You have to read the comment.
yeah, I'm getting
Okay, thank you. So you see inside the admin one, yeah?
but the answer is not having two.
The answer is what?
Is it not having one?
No. The first color, the color are representing admin one.
Ah, yes.
But inside the color, you have other boundaries.
Okay.
And these boundaries are representing the admin two.
Yeah.
Yeah. So now we can maybe swing to add the text inside these boundaries. So let's add this here by uncommenting this zone SF text. It will add the name of admin one inside the map, but we have to put here plus to say that we are adding new line, the join plot function. So when you run this now, it's showing you the names here. But with some text, so it means when you are going to maybe present this kind of map, adding here the text inside is not necessary because in your legend it's showing well the limitation of every boundary. Or let's come back to the default one, and or you can think to change the color. Say so this color, so I want a different color. Example. So you have this scale field varies, which can allow you to change the color. For example, if you choose the option equal maybe plasma, let's run this to check. You see now you have a different color, so you can decide which color, which palette of color do you want in your map, and there are plenty of palette color, so you can check online to select your adequate palette color. So from here you can run it again to check what we are getting. So for me, let me share what I'm getting. So you see, I'm getting this, and up to the end, I'm getting this. You see how nice and clear is this working with Quarter? So we encourage you to write your report or some analyzing document with Quarter where it's allow you to show even the script and add some text or interpretation also. But also you remember it allow you to add references or links. So yeah, 15 minutes, 8 minutes. So, were you able to run to get this map? Okay. So after this, we want to reach a CSV file, okay, and just maybe inspect, check, aggregate variables. I hope you already it's visual and data visualization, data wrangling. You know how to manipulate your CSV file. So let's read this. Just create first. Create first your new meeting. Let's read our CSV file. So seeing we don't have much time. So maybe if someone has some comments or suggestion, or we can come back to something before, instead of continuing running, because you will have the clean version. I will send you the clean version one. We will continue to fill this. But here the most important was to know what is vector data, what kind of vector data do we have, what are the components of the shapefiles, what is the CRS, how to move from one to another CRS, and how to make a simple map, how to recognize the different attributes of a shapefile. I think these are the most important here, and the rest is just data manipulation. You can then merge or join this file to your survey data with the name, use the same name of column, and then continue creating your fancy map. Because of the time limiting, I am going to stop here and ask you if you have any question, or put down if you can contribute in something. Please feel free.
So I've added a couple of additional resources that include videos. So this was done in a hackathon for Amnet. There's an English version and a French version, and I put the links in the chat. So folks, if you are more than welcome to look at that, because this is a pretty important session. I also kind of want to get a feel from the room if you guys might want to do an office hour where you simply practice the vector stuff this week.
Yeah.
So please quick thumbs up or a yes in the chat if you would like to do a 1 hour extra office hour this week, and we can try and find some time, perhaps I'm thinking on a Friday maybe, but we'll check with Usman's schedule. But we can do just a 1 hour like office hour where we just work through maps, like making these maps in R.
Yeah.
All right, so I have a thumbs up.
Thank
Awesome.
you.
Witness, Sylvia and Victoria, we had a thumbs up from, so that's 3.
Yeah.
So if we get at least about 5 people saying yes, then like we can definitely do this.
Yeah, exactly. Coconut, we can take lots of list people who want to have extra. Yeah.
So what I'm proposing is a 1-hour session on Friday where we just practice making a map in R. Like we will do it together, like we just practice this.
Yes.
So a thumbs up or a yes in the chat, please, would be great. So I know that we know the numbers. We're looking for a 5 majority. All right. So I've got 4 people so far. Well, Victor counts twice, so I got 3 people so far.
Kaila is here. Kaila is and Rosalie, Rosalie house.
All right. I think there's enough people. Like, so we will send out a Zoom link for an extra office hour session this week, just to practice vector data in R. Spatial vector data, because we're talking to a bunch of entomologists.
Okay.
Awesome.
Yeah. And thank you so much, guys. And see you Fridays then. And I hope this was very useful. And you will continue to create fancy map inside.
Just a reminder, guys, please don't forget to fill in your post-workshop surveys. I'm putting the link here as well. It's in the chat. Please, please, please. They are so helpful for us to know if like you are learning and if we need to change stuff. We have tried to make them simpler for you guys. So please, please, yes, with all the buzzing, please, please fill in your post-survey workshop.
Okay. Bye. Thank you, guys. Bye.
Bye.
Thank you, Kunal and Yasin Kokona, for facilitating this.